So, good afternoon, class. So far, we had discussed regarding the complex number, and so far we had discussed the various parts related to the complex number. We had already studied and we had seen how to represent the complex number. And whenever we are saying a complex number, it is a part of two things, two entities, where the complex number z, we are representing the complex number with the nomenclature as z, and it is a combination of the two parts, the real part as well as imaginary parts. The z is equal to a plus ib, where a represents the real part of the complex number and ib represents the complex part of that complex number. So it is a is the real part of the complex number, which we are writing as real part, and ib, this is the complex part of the this number, that is complex number. So this is the basic part of the complex number. Z is equal to a plus ib, where z represents any complex number and we are representing any complex number in the form of a plus ib, where a represents the real part of that complex number and ib represents the imaginary part of that complex number. Suppose, and so far in the journey of the complex number, we had discussed the various properties associated with the complex number. One thing we had studied, that is iota, and it is basically I. I is basically the iota. It is denoted as I is equal to iota, which is defined as the basic entity of any complex number. Secondly, so far we had discussed in the complex number pertaining to the basic the operations which we are dealing with, the mathematical operation which we are entitling as mathematical operations, and we had seen the various parts such as addition. We had seen the addition part and the properties associated with the addition. Suppose there are various type of addition part is there, the complex number is there, entity is there, the associative property is there, the distributive property is there. So that is basically the addition part. So today we are discussing about the subtraction part, and we will see how we have to proceed regarding the complex number, and how we are using the principles of complex number in order to solve the tedious numerical problems, and it is basically related to the subtraction of the complex numbers. We will see here and we will check also. So if we are considering the subtraction part of two complex numbers, the first part is z1. Z1 is equal to a1 plus ib1. We had just we had taken a complex number which is written in the form of z1, and it is basically the two parts, a1 plus ib1, and z2 is equal to a2 plus ib2. So we have taken two complex numbers, z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2, and we will see and we will check how we are subtracting, how we are performing the operations entitled as subtraction of these two complex numbers, and we will check also further part. And we will check also how we are using the complex number part. So z1 is equal to a1 plus ib1. So z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2. And we will see how we are subtracting these two complex numbers together. So z1 minus z2. So we have to see z1 minus z2. In this case, z1 minus z2 will be equal to, first of all, we will take the real part together. For performing any operations, we have to classify both the real part as well as imaginary part. In order to perform any mathematical operations which is induced with a complex number, in that case we have to first of all see what all are its real part and what all are its imaginary parts. So z1 minus z2, we will see the real part here, that is a1 minus a2, and regarding the complex part, we will see, we will just take I common. I will be common, b1 minus b2. So we had seen how we had just subtracted two complex numbers. We had taken two complex numbers entitled as z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2, and we had solved the basic we had used the basic principle of the subtraction here. First and foremost, we had taken the real parts together as well as imaginary parts together. So considering the real parts, it is a1 is the real part and a2 is the real part and I is the common here. So b1 minus b2. So basically we are getting one expression as a1 minus a2 plus I b1 minus b2. So that is the basic procedure for solving the subtraction of the complex numbers. Now we will be moving to the multiplication part. How we are solving the moving ahead of the multiplication part. In the case of multiplication part also, we will consider two complex numbers. Z1 is equal to A1 plus IB1 and Z2 is equal to A2 plus IB2, and we will multiply both these entities using the basic principles of the mathematical operations, and we will check how we are just multiplying these two expressions. So we are basically considering the multiplication part now. So we have seen the subtraction part. We will be moving to the multiplication part now. And in all these cases, we had used the basic principles of the mathematics that we had already studied in our lower classes. In the case of multiplication of the two complex numbers, so we will see Z1 is equal to x1 plus I by 1 and Z2 is equal to x2 plus I by 2. Understood? So we have taken two complex number entitled as Z1 is equal to x1 plus Z1 is equal to x1 plus I by 1 and Z2 is equal to x2 plus I by 2. So we will see here whenever we are multiplying these two entities, we will write here Z1 into Z2. In the place of the symbol into, we are using dot here. Z1 into Z2 is equal to, we will first of all take the real parts together. So in this case, the real part is x1 into x2 plus. Now in these two entities, I is common. That is iota is common. We will take I outside, y1 into y2. So this is the basic operation. We had taken two complex numbers. Z1 is equal to x1 plus I by 1 and Z2 is equal to x2 plus I by 2. Whenever we are performing the mathematical operations induced with the complex numbers, we will see what all are its real parts. We will take both the real parts together. So x1 is to x1 into x2, and we will separate the iota part. We will take I as a common I and y1 into y2. So that is the basic operations, that is the basic expressions, final expression related to the multiplication of the complex number. We will see with one or two examples which will render more transparency. So in this case, we will check the basic mathematical operations and we will move on. Suppose. So in this case, we had seen x1 into x2 and y1 into y2. We will see also. Suppose we have to, in this case, Z1 into Z2, this is the basic operation which we have performed here, and we will see also how we are calculating the final expression. In the case of Z1 into Z2, it will be x1 plus I by 1 plus x2, into it is into multiplication dot into x2 plus I by 2. So using the basic mathematical operation, we will multiply both these entities, that will be x1 into x2 plus, we will see it is here x1 into I by 2 plus I y1 into x2 plus I square y1 into y2. So that is the basic expression here. Whenever we are multiplying, we will be using the basic principles. So x1 into x2 plus x1 into I by 2 plus I y1 into x2 plus I square y1 into y2. So it is basically x1 into x2, x1 into x2 plus, we will take I as a common, x1 into y2 plus y1 into x2 and I square is minus 1. So it will be minus y1 into y2. So it is basically x1 into x2 minus y1 into y2. We will be taking the real parts together, and the part which is associated with the iota, we will separate out those entities. So it will be I x1 into y2 plus y1 into x2. So we had seen here how we had performed the mathematical operations pertaining to multiplication. So this is the basic answer. This is the basic expression which we had got as a result of the multiplication of the two parts, and we will see here how we are performing the basic operation here. And now we will be moving ahead to the properties of multiplication. We had seen the basic operation, how we had calculated the product of the two complex numbers together. Now we will be moving ahead for the properties associated with the multiplication of the two complex numbers. The first property is it is commutative in nature. The first property is it is commutative in nature. So this is the basic result. Now we will see that first property is commutative in nature. Commutative in nature, we will see how we are proving it, how we are proving those entities. So that will be easier for us to understand the basic concept. Understood? So it will be, suppose this is the only example. The first property is that multiplication part is commutative in nature. So Z1 into Z2 is equal to Z2 into Z1. It is commutative in nature. So the product of the two complex numbers are commutative in nature. So in this case, Z1 into Z2 is equal to Z2 into Z1. So first of all, we will perform Z1 into Z2. We will see the result. X1 plus IY1 into X2 plus IY2. So in this case, we will get X1 into X2, X1 into X2 plus I X1 into Y2 plus I Y1 into X2 plus I square Y1 into Y2. Understood? So how we had performed the basic operations, we had dealt just a couple of minutes ago. So we will be seeing here x1 into x2 plus I x1 into y2, similarly plus I y1 into x2 plus I square y1 into y2. So x1 into x2 plus I we will take as a common, x1 into y2 plus y1 into x2 plus I square is minus 1 y1 into y2. So we will see here x1 into x2 minus y1 into y2 plus I x1 into y2 plus x1 into y2 plus y1 into x2 plus y1 into x2. So this is first part which we had seen. That is, when we had multiplied both the entities, we had got this expression as x1 into x2 minus y1 into y2 plus I x1 into y2 plus y1 into x2. This is the first expression. Now we will multiply by changing the position. We had used Z1 first and Z2 next. Now we will be using Z2 first and Z1 after that. So we will be multiplying again Z2 into Z1. Z2 into Z1. We will see the result, the outcome of that, and we will verify, cross verify whether it is commutative in nature or not. So whenever we are multiplying with Z2 into Z1, now we are multiplying with Z2 into Z1. Now it will be Z2 into Z1, it will be X2 plus IY2 into X1 plus IY1. Understood? So we will be using the mathematical operations which will be easier for us. So it will be x2 into x1, x2 into x1 plus I x2 into y1 plus I y2 into x1 plus I square y1 into y2. Understood? So we are getting the result as x2 into x1, x2 into x1. See, I square is minus 1. So we will be using directly there minus y1 into y2 plus I is a common, x2 into y1 plus y2 into x1. So it is second equation. So we will be seeing here that is x2 into x1 minus y1 into y2 plus I as a common, x2 into y1 plus y2 into x1. So we are seeing here 1 is equal to 2. So it is Kuhn error demonstrated that the multiplication of the two complex number is commutative in nature. So we had proved also, we had established one relationship that multiplication of the two complex number is commutative in nature. So that is Z1 into Z2 is equal to Z2 into Z1. That is commutative in nature. We will see the other property also which will render more transparency. And it will be easier for us to understand the basic concept induced with the complex number mathematical operations. The second property is it is associative in nature. The second property is the complex number, the multiplication is associative in nature. So the multiplication is associative in nature. Associative. So it will be Z1 into Z2 into Z3 is equal to, suppose this is the complex number which we are using. So it will be Z1 into Z2 into Z3 is equal to Z1 into Z2 into Z3. So that is the basis. Suppose we have to prove that the product of three complex numbers are associative in nature. Earlier we had seen the product of two complex numbers are commutative in nature. Now we are seeing the product of three complex numbers are associative in nature. So in this case, similarly, we will be taking one example. Z1 is equal to x1 plus y1. We will be following the same nomenclature for other complex number also, but we will be changing the notations. So Z1 is equal to x1 plus iy1, Z2 is equal to x2 plus iy2, and Z3 is equal to x3 plus iy3. So that is basically the part. So Z1 into Z2. Whenever we are multiplying the two complex numbers, we will be writing those two complex numbers separately. So it will be Z1 into Z2. Suppose we are multiplying these two complex numbers. So it will be x1 plus iy2 into x2 plus iy2. So it will be x1 plus iy1. Mistake, I have written 2 here. It will be 1. It will be x1 plus iy1, and secondly it will be x2 plus iy2. So it will be x1 plus iy1 and x2 plus iy2. Now we will be multiplying it x1 into x2 plus I x1 into y2 plus I y1 into x2 plus I square y1 into y2. So it will be x1 into x2 minus y1 into y2 plus I x1 into y2 plus y1 into x2. So that is the basic operation, that is the basic expression whenever we are multiplying two complex number together. Now we have to multiply the product of Z1 into Z2 with Z3. We had taken Z3 as x3 plus I by 3. Now we will be using x3 x3 plus I by 3 x3 plus I by 3 with this full expression, that is x1 into x2 minus y1 into y2 plus I x1 into y2 plus y1 into x2. So we had used the curly bracket here in order to have our mathematical operations in a convenient manner. So we are just multiplying with this basic operation here. So it will be, whenever we are multiplying this one part, x1 into x1 into x2 x3, then x1 this plus I this one. So it will be x3 into x1 into x2, understood, minus, it will be minus x3 into y1 into y2. The first expression which is completed here. Again we are multiplying this one with this one, plus, it will be plus I x3 into x1 into y2 plus x3 into y1 into x2. Understood? Now we are using this part. I will be here I y3 into x1 into x2 minus y1 into y2 into y3. Again we are multiplying this one part here. So it will be I into I minus I square, that is minus y minus y3 into x1 into y2. It will be minus y1 into x2 into y3. So that is the basic operation which we have performed here, and we have seen also this is the first expression. This is the first expression. Similarly, we will be using these two together, Z2 into Z3 together, and we will be multiplying these two entities with Z1, and the conclusion is we will be finding that Z1 into Z2 into Z3 is equal to Z1 into Z2 into Z3. So we had seen and we had established also that product of two complex numbers are associative in nature. We had seen also. And similarly, we will be showing the other examples also, which will render more transparency and will be easy for us also. We will take I common here. Similarly, x3 x1 into y2 plus x3 y1 into x2 minus plus y3 into x1 into x2 minus y1 into y2 into y3, and this will be same, and we will be seeing here how we are. So we had, so far we had discussed two parts, the two vital parts related to the complex number. The first one was the multiplication. The property of multiplication was commutative in nature. So we had seen Z1 into Z2 is equal to Z2 into Z1. Secondly, we had seen the product of two complex numbers are associative in nature. That is Z1 into Z2 into Z3 is equal to Z1 we had taken out and Z2 into Z3 into the consolidated form. So we had seen the product of two complex numbers are associative in nature. Now furthermore, moving ahead, we will be seeing that there is an identity element for each multiplication. Suppose if any complex number is there and we have taken that complex number in the form of Z is equal to A1 plus A plus IB, and we will be multiplying that complex number with 1, and we will be seeing what is the result. So that is basically the identity of that element for the multiplication. The third property is existence of identity element for multiplication. We will be saying here, so Z into 1 is equal to Z is equal to 1 into Z. So that is basically the existence of identity element for multiplication. The third part is we will be saying the existence of identity element for multiplication. So far we had discussed the two parts today. In the multiplication only, the subset of multiplication, the properties of multiplication we had seen, the commutative nature and associative nature, and the third part is the existence of the identity element for the multiplication part. Understood? We will be seeing those part also, so it will be easy for us. So it will be easy for us, and we will be saying the various content. So far we had discussed the two parts, the two vital parts of the two wings of the complex numbers. The first one was the subtraction of the complex number. We had seen how we had subtracted two complex numbers. Moving ahead, we had seen how we had multiplied two complex numbers together, and we had seen how what are the properties associated with the complex number. The first property was the commutative in nature. So Z1 into Z2 is equal to Z2 into Z1. The Z1 denotes the complex number which is bearing A1 plus IB1 and A2 plus IB2. Secondly, we had seen that the product of the two complex numbers are associative in nature. Suppose Z1 into Z2 into Z3 is equal to Z3 into Z2 into Z1. So third property is existence of the identity element for the multiplication associated with the complex number. We had seen, and we will be saying also. The third property is existence of identity element for multiplication, and this is basically dedicated for the complex numbers multiplication. In this case, suppose any complex number is Z. If we will multiply that complex number into 1, it will be equal to Z, and it will be equal to 1 into Z. And we have to establish, we have to prove also Z into 1 is equal to Z, and in the right hand side it will be equal to 1 into Z. In this case, suppose we had taken any complex number, it will be taking in the form of A plus IB. We had taken any complex number which is written in the form of A plus IB, where A denotes the real part of the complex number and IB denotes the complex part of the complex number. And whenever we are writing as 1 we will write here, suppose 1 if it is there, 1 plus I into 0. Whenever we are writing any natural number, we can write that natural number as a bifurcation, of two parts, that is real part as well as imaginary part. And we had written also one in the form of real part as well as imaginary part. In this case, the imaginary fraction will be 0 and the real part will be 1. Now we will be multiplying this also. So Z into 1, A plus IB into 1 plus, suppose we are writing as 1 plus 1 plus I into 0, 1 plus I into 0. So it will be equal to A into 1, understood, plus I A into 0, that will be equal to plus A into 1 plus I into 0. So it will be equal to A plus IB. A plus A into I0, A into I into 0, plus similarly it will be equal to, so this is basically I, 1 plus IB, A we had already multiplied, A into 1 plus A into I into 0 plus I, it is I into B into 1 plus I square B into 0. So we will be seeing here, it will be equal to, this part will be equal to 0. This part will be equal to 0, I square minus 1, this part will be equal to 0. It will be equal to A plus IB. That is basically Z. So we have proved two parts here, Z into 1 is equal to Z. Now moving ahead to the right hand section, that is 1 into Z. Now we will be multiplying 1 into Z and we will be cross verifying the result, and that will basically prove the analysis. So 1 into Z, whenever we are using 1 into Z, we will place 1 before, thereafter we will place Z. So placing that 1 into Z, so it will be basically 1 into Z. Whenever we are using 1 into Z, so it will be 1 plus I into 0 into Z. Z is basically A plus IB. Now if we are multiplying 1 into Z, so 1 into A, first of all 1 into A, similarly IB, 0 into 0, it will be 0 into A, it will be basically 0, and I square minus 1 into 0, it will be basically 0. So we are getting the output as A plus IB, that is basically Z. Now we had seen that Z into 1 is equal to Z is equal to 1 into Z, that is quod erat demonstrandum. So we had seen the third property, that is basically entitled as existence of identity element for the multiplication. We had seen if we had taken any complex number and if we are multiplying that complex number with 1, now we will be getting the result as Z into 1 is equal to Z is equal to 1 into Z. That is basically the proofing part that we had established, and we had seen also how that basic outcome comes here. So we had seen the various properties associated with the multiplication of the two complex number. Prior to that, we had seen the subtraction of the two complex number. So for today, this two part is sufficient, and if any issue is there, just ping a message, and I will just introspect on your queries. Whatever queries are there, I will try to resolve that query within the shortest possible stipulated time. Till then, thank you for the day.